Hello and welcome to lecture number 2 of the LQAS online series. In this lecture, we will address considerations when collecting data using LQAS in a quantitative survey, especially in surveys conducted at the household level, including KPC baseline surveys carried out at the beginning of a project. Objectives for this particular lecture include how to randomly select communities for a quantitative survey conducted using LQAS, how to randomly select households in those communities that have been randomly selected for a survey, and when to use parallel sampling and some key data collection implications for doing so. By the end of this lecture, we would like you to understand the overall process of data collection with the intention to reduce any survey bias in order to obtain quality data. In order to identify the location for conducting the interviews in each supervision area, there are 5 basic steps to do so. First, we would need to have the listing of all communities or towns along with their total population in which the project will implement activities. Second, with the population size for each community, we would calculate the cumulative population for the supervision areas. Third, we will calculate a sampling interval that will help us to identify locations of the interviews. Step number 4, we will pick a random number from a random number table. And finally, in step number 5, with that initial random number and the sampling interval, we will be able to identify communities for the 19 sets of interviews we need to conduct in the supervision area. Going back to our example of 5 supervision areas in our project catchment area, we will need to obtain the listing of communities along with their population size for each supervision area and conduct the same process that I am about to explain in the next few slides in order to randomly select communities and households for each of them. The first step is to obtain the listing of all communities in each supervision area along with the population sizes respectively. Let's take a look at an example of how we can do this in supervision area A. As you can see, what we're going to do is in a table to list all the communities or towns located in supervision area A, and we're going to include also the total population for each of these communities or towns in this table. So at this point, we are going to work with a table that has a couple of columns, one with the names of the communities or towns in supervision area A, and in the second column, the population size for each of the communities or towns. And at the end, you will see that the total population size that will correspond to the total population of supervision area A. Once we have this information with the communities and their population size respectively, we're ready to go with the step number 2 to calculate the cumulative population. And in this table, we're going to add a third column that we're going to list all this cumulative population. And the process will be the following. For the first cell in the cumulative population, we will copy the first population size from the first community. In this case, the community is called Tagay, that has a total population of 548, and then we're going to copy that total population in the first cell of the cumulative population column. To obtain the second cell in the cumulative population column, what we're going to do is to add the population size of the second community to the previous cumulative population cell. And that's the way we're going to get the cumulative population for the second cell. In this case, 548 plus 730. That will give us 1,278. To get the third cumulative population cell, we will again add 686, the population size of the next community, and we're going to add that to the previous cumulative population cell, that is 1,278, in order to get the cumulative population of 1,964, and so on, to get the rest of the cumulative population cells. 1,964 plus 280, that will result into 2,244. Next, 2,244 plus 1,256 will give us 3,500 for the cumulative population. And this process will be repeated all the way down to the very last town or community, and we will be able to match at the very end the total population size with the last cumulative population cell. For this particular example, 23,489. Once we get the cumulative population, the next step, step number 3, will be to calculate what we call the sampling interval. And the sampling interval, it's mainly obtained by dividing the total cumulative population over the sample size that we want to get for this particular supervision area. As explained in lecture number 1, our optimal sample size when using LQAS will be 19. Therefore, the sampling interval would be the total cumulative population in each supervision area. For this example, we're talking about supervision area A over 19. In other words, we will divide 23,489 over 19, and that will give us the number of 1,236.26. That will be our sampling interval for this particular supervision area. Step number 4 calls for the need to choose a random number. The random number has to be between 1 and the sampling interval value. So for our example in supervision area A, we need a random number between 1 and 1,236. The decimal points are not used in this particular step. To do this, we first need to identify the highest number of digits in a random number, which for our example would be 4, since we're talking about 1,236 that has 4 digits. To pick the number, the random number that is, we're going to make use of a random number table. Although there are many other ways to get a random number picked, we're going to explain this particular one using a random number table, and we will go over some other examples in the live session a week from today. Since each row for this particular random number table has 5 digits, we would randomly select the first 4 digits of a number. So with our eyes closed, we can bring a pencil into the table of these random numbers to select a group of 5 numbers. If the first 4 digits of the number is in the range of 1 to 1,236, which is the number for our example, then we will pick that number as our starting random number. If not, we will move to the next row of numbers until we get the 4-digit random number that we are seeking between 1 and 1,236.